All right, ladies and gentlemen, good afternoon. The class recording has started. So, anything that you don't want your mom or your grandma to hear, don't say it anymore. Got it? All right. Yesterday we introduced, or we kind of went over these concepts of energy, and we talked about two specific types of energy, right? First we talked about kinetic energy. That's energy of motion, right? Something is moving and it has the ability to move or change other things. And then we also talked mostly about gravitational potential energy based on the location of an object relative to Earth or some other source of gravity. Just Earth is the one that we use most often. It has the ability to move or change things, like smash this coconut down here. Why you would lift a huge crate up onto this ledge just so you can smash a coconut, I don't know, but you could if you wanted to. Okay? All right. We talked about the different factors that influence how much kinetic and potential energy an object will have. Kinetic energy is influenced by two things, mass and speed, right? And we talked about that mass is directly related, speed is quadratically related to how much kinetic energy that object has. Gravitational potential energy is influenced by three things: the mass of that object, the height that it is above the ground, and then this G factor, which we said basically summarizes the effect of gravity. And here on Earth, even though you can't see it if you're watching the recording, I'm pointing over here on the side, right here on Earth, that value is going to be 9.81 meters per second squared. That summarizes the effect of gravity on things here on Earth. Okay? Good there. All right. So if you would, open up your packet that I gave you yesterday, the one that looks like this. Oh, I don't have it open. I thought I had it open, but apparently not anymore. This packet right here that says Math Skills, Gravitational Potential Energy. And turn to page 24. So down at the bottom of page 24, there's a section listed as practice. We're going to start off with practice problem number 5. And here's what I want you to do, okay? In my opinion, the questions that we're going to do today get increasingly more difficult, okay? If at the end of class you were like, none of these are very hard, cool. You're good then, you're right? But the ones we're going to do are going to get increasingly more difficult as we go along. What I am going to do today is this. I will introduce the problem to you, and then I'll say, hey, let's work on it with the person next to you, or if you want to do it by yourself, that's cool too. But up on the board, I will slowly write things up on the board so you can see how you're doing and if you're on the right track and if you're getting the information you're supposed to be getting, okay? All right. So the first problem I want you to do is at the bottom of page 24. It's question number 5. It talks about people in a village of Aquanquilac. Nope. Anybody speak Spanish? Anybody? Anybody want to try this for me? Alcanquilca? Alcanquilca? It's a town in Chile that is the highest inhabited town in the world. All right? So, here's what I want you to do. I want you to go through and I want you to solve this problem. Now, yesterday we went through a process of identifying different things, what we're looking for, what information was given to us. I'm not going to require that you do the questions with that process, but I will do them that way up on the board. I think it's a good way of just keeping us organized, all right? So, let's take a couple minutes. Talk to the person next to you, work with the person next to you, in front of you, behind you, something like that, or do it by yourself, and let's go through this problem. I will start putting information up on the board here slowly as we go along. Go. Alright, so up on the board is all the information that I got out of this problem, including one thing that wasn't given to us in the problem, right? This effective gravity, even though it's not specifically stated, we can always assume that if we're doing a problem here on Earth. Okay? Carry on. Okay. Let's go through it here in just a second, okay? All right. So take 30 more seconds, finish this up, then we'll go through the steps in the process here, okay? All right. Are we ready to go through this? Yes? Okay. So, any problems with the numbers on the left-hand side of the information that I pulled out of the story problem? We okay with those four things? All right. Are we good with this being the equation of calculating how much gravitational potential energy we have? Okay? Any problem with us plugging those numbers into those spots in the equation? Okay. Any problem with this number, running it through the calculator? Okay, good. Those are the important parts. Now let's talk about the end parts, okay? First, let's talk about units, okay? We got kilograms here. We got meters over seconds squared here. We got meters here. With where those units are and what they are, nothing cancels anywhere. Nothing cancels anywhere. So what I just did was just multiplied them all together, and I end up with this big mess over here on the right-hand side. Okay? But hopefully we remember that that big mess of units is the one that we summarize with capital letter J for joules. Okay? So that's how we turn this big mess of units into this capital J. Now, let's talk about the rounding. Okay? Mathematically, what type of mathematical operation are we doing here? What math operation did we have to do? Multiplication. When we are multiplying numbers together, measurements together, we always round our answer to the lowest number of significant digits of any of our original measurements. Okay? My numbers in pink over here represent the number of significant digits in each of those measurements. Are we cool with those pink numbers? Okay? So that means that we're going to have to round our answer to 2 places because 64 has 2. Starting from the left-hand side, 3 is going to be a significant digit. It's non-zero. The next 3 is going to be a significant digit. It's non-zero. So I drew my line. I look one place past that. Do I have to round? No. However, I can't just drop all of those numbers, right? There's a big difference between 33 and 3,300,000, right? All of these remaining places, we will make them zeros, but what can't we do? Can't put that decimal point at the end. Putting the decimal point at the end makes all of them significant. Without the decimal point, none of them are significant. And that only has 2. Good? All right. Flip back to page 23. Flip back to page 23 if you would. And down at the bottom of page 23 in the practice section, question number 3 is about a Cuban high jumper named Javier Sotomayor when he set the world record in the high jump. Work with the person next to you. Go. Or work by yourself. It's fine. Hold on one second. If it would make more sense, go ahead and plug the numbers into this equation and then solve that way. That's okay. Okay? So what I'm doing here, right? We need to solve for h, yes? So I need to get h by itself in this equation. Okay? So all I did, I divided the right-hand side by m and g, because that canceled these out here. But if I do that to one side of the equation, I got to do it to the other side of the equation, and that's where this ended up here. Okay? Does that make sense? Elizabeth, if it makes more sense to put the numbers into these spots first and then solve for h, go for it. That's fine too. Okay? I don't care how you do it. If you get to the right answer, it's fine. All right, talk to me. How are we doing here? Anybody have questions that they cannot resolve as part of their group? Good? Good with the rounding at the end? All three of these answers have 3 significant digits, so I rounded my answer to 3 significant digits. Okay. Give me a thumbs up. We good? Yes. All right. Next, let's flip it over to the last page of the packet. Is 27 maybe? 27. Okay. So, in case you didn't notice, right? The second part of the packet, we transitioned from gravitational potential energy to kinetic energy. Okay? Different formulas, but the concepts stay the same. So, at the bottom of page 27, there's a question about a cheetah. Go ahead and answer this question about a cheetah. Okay? Page 27, yeah, question number 6 on page 27, the last page. So go ahead and answer this question about the cheetah. is 1/2 a measurement in this problem. It's just part of the equation, so that doesn't count. Okay? Yeah, only measurements. That's where we get our significant digits from. Okay? All right, talk to me. Anything? Good? Yeah. Good with the rounding and everything? Okay. All right. So, next is what I would consider to be the most difficult problem that we will have done today. Okay? On the previous page, page 26, down at the bottom, there is a question about a Shinkansen bullet train series 200. Okay? Go through your process. All right? It's in a Ziploc bag. Right. 26, the one right before. Is it appropriate, or is it? It is appropriate, I promise. But wait, let's finish this calculation and then we can close with a joke. Okay.
That'd be a great way to end the conversation.
You don't have to. If you know how to do scientific notation in your calculator, feel free to leave it that way. In my experience, I have found that a lot of people don't know how to use scientific notation in their calculator, so it might be a little easier just to change it into this form.
Okay, I think don't change it into the mass, and then I realized you didn't do the equation yet.
It says that that's the maximum kinetic energy, but that's what they want you to use because that's the only value they gave you. So. this is the microphone right here. So don't say anything mean.
They said that it was like KE times 2 over 2 squared is the same thing. Because I think you cut the zeros, so there's like a bunch of zeros out of it. What is that?
You can't just cut those zeros.
Well, it can be
Well, here. So this is what I just did here. This is I just moved the decimal place over 9 places. Right?
That's a lot.
There's a lot of zeros, I know, but it does make a difference in your answer. That's why my answer is that big. So
I think it was probably closer. But we have a 9 in the...
that's good.
We did...
Yeah, you might have like the beginning of this, but
Oh, I have a 9 in 5 too. But I don't know what happened. I was doing it and then something... Then it started saying error. I did...
oh, here. So go like here. You move your decimal place, but then you have a multiplication sign and a division sign with your next to each other. It is not. That is not. It doesn't know what to do with it. Okay?
So what I did is I did 2 times that, and then I pressed enter, and then I did the answer divided by that, and then it showed me that. Why did that happen?
So if you hit second and answer, it'll put the last calculation
You failed.
like up on the board. So here, hold, let me finish this number up here real quick.
Why is it 2 KE and not
Okay.
KE times 3?
So that's the same thing, right? 2 times KE over B
Oh,
squared.
because we didn't put the zeros in it.
Well, that shouldn't change. That shouldn't change this step though. Like your step here should be the same, right? Because that doesn't have any numbers in it. So.
Joke, there's 30 seconds left.
Oh, I gotta tell a joke.
For the class recording, you got this.
Hold on.
Oh yeah, that's the microphone.
I went to the bank the other day and asked the banker to check my balance, so she pushed me. Ha ha ha.
What was that laugh? That was a good laugh. That was solid. That was solid.
All right. I know the class is almost done here, but I just finished off the problem on the bottom of the board right here, so you can see what the answer is. Okay. So. Didn't show you the units because I was talking to people, right? So this, I'll write you a pass, by the way. So this is joules, right? Okay. So just from a, here, let me do this. There's more practice from the book that's listed, but it's just calculations like this. So, so if you look, I think on Mr. Planasek WHS, or hold on a second, let me check. Stay there, Alex. I can't remember what my name is on here. Let's see. I am Mr. Planasek WHS. Okay. Okay. So, Elizabeth, you see that this I can substitute in for joules? Okay. And so that's going to be on the top. And then on the bottom, we're going to have 76.4. And that's meters per second, but we're squaring that whole value, okay? So here, when you square meters over seconds, you get meters squared over seconds squared. Does that make sense? And so that cancels that, and that cancels that. And then the only, even though this is meters and seconds, when you, this is just meters and seconds, and then this is squared though, because when you square it, you'll get, that's what you'll get, right? So that's where these meters squared cancels these meters squared, blah, blah, blah. And then the only unit that's left now is kilograms.
Okay, so you basically just cancel out all the other units?
Yes. The way it works out, if you have your energy in joules, your masses in kilograms, and your speeds in meters per second, the units will always cancel out to give you what you're supposed to have. So in this case here, you had a speed and you had a kinetic energy, and the units canceled out to give you kilograms because you were looking for mass, and that's what mass is supposed to be measured in. So as long as all your units are in kilograms and joules and meters per second, it'll turn out the right way. If they gave you a mass in like grams instead of kilograms, you'd have to do a little conversion first to make it come out the right way, but I won't give you any problems like that on the quiz. So, okay.
All right.
Is that good?
Yeah, that
Okay.
makes sense.